The Center for Transportation Studies at the University of Virginia is pleased to announce a workshop on Modeling Stormwater 1 and 2 Best Management Practice. This two-day workshop is conducted by Jonathan Goodall and Partha Sarathy.
The goal of the workshop is to enable the participants to design stormwater management facilities with a detailed understanding of hydrologic and hydraulic modeling tools and techniques available to support the design of practices intended to control and mitigate the negative effects of stormwater runoff according to Virginia Stormwater Management Handbook and Runoff Reduction Method or energy balance equations requirements.
In this webinar, we provide a brief overview of the material that will be presented within the two-day workshop. Participants in the workshop will carry out a design of 3 practical examples from start to finish, touching on regulation through the design experience.
Virginia stormwater management regulations have evolved over time. There used to be days when BMPs were designed based on technology and performance-based criteria. The latest stormwater management and VSMP permit regulations have been developed by the DEQ and are in place effective July last year. The regulation requires that all operators shall develop, implement, and enforce procedures to reduce pollutants in a stormwater runoff to the regulated small MS4 from construction activities. Any land disturbance 1 acre or more come under the purview of these regulations. There are situations where more stringent requirements would apply. In areas subject to Chesapeake Bay Preservation Act, all land disturbance 2,500 square feet or more will need permitting. The regulations further require that water quality compliance for each hydrological unit code or HUC of the development project, except in cases where compliance is achieved under a comprehensive stormwater management plan. Water quantity control for channel and flood protection is also required for each outfall where the stormwater leaves the project right away from the receiving channel. An additional feature of the new regulations is that certain projects will be grandfathered until June 2019. Under technology-based criteria, post-development water quality volume from the impervious area cover shall be treated by an appropriate BMP as long as post-development water quality volume for impervious cover, if it is in excess of 16%, shall be treated by an appropriate BMP according to Table 1.
In the performance-based criteria, there are 4 situations that could apply. The first situation is where the existing percentage impervious cover in the watershed is less than the average impervious cover for the region, which is typically assumed to be 16%. And the total proposed impervious area is also less than the average impervious cover for the region. In this situation, no reduction in pollutant discharge, and therefore no BMP facility, will be required. In situation 2, the existing impervious area in the watershed is less than the average impervious area for the region, but the proposed impervious cover will be greater than the average impervious cover for the region. In this situation, the post-pollution discharge must be less than the pre-pollution discharge. Situation 3 is where the existing and proposed impervious cover for the watershed are in excess of the average impervious cover for the region. In this situation, the post-pollution discharge should be the higher of 90% of the pre-pollution discharge or the pollutant discharge of the average land cover for the region. And lastly, situation 4 of the performance-based criteria applies if there's an existing BMP on the project site. In this situation, the post-pollution discharge will account for the pre-pollutant discharge served by the BMP.
As for the water quantity control, the channel erosion volume should be based on MS19 criteria, most of you would be aware of, and also the flood protection criteria where Q10 post should be less than or equal to Q10 pre. 1% rule applies where the receiving channel has an area which is in excess of 100 times the contributing drainage area from the project. No water quantity control is required. VDOT has its standard performance-based water quality sheets, which will help you guide in determining type of facility required for water quality. The participants will be able to work through these spreadsheets as well. Coming to part 2B of the regulations, without the new regulations, we have to understand the design philosophy first. If the storm water runoff with X pounds of pollutant load goes directly to the receiving channel without any BMP, then the receiving channel will receive the total amount of pollutant load the same as before. If, however, we provide a BMP which will reduce the pollutant load by, let us say, Y%, then the receiving channel will get X into 1 minus Y by 100 pounds of pollutant load. If we are able to provide a BMP which will not only reduce the pollutant load but also reduce the total runoff to the receiving channel by a certain percentage, then there will be a substantial reduction, not only due to the reduction in the runoff, but also the reduction in the pollutant load. So the receiving channel will receive much less pollutant load. So instead of providing a BMP at the end of the outfall for each receiving channel, we will try to minimize the runoff by either preventing the pollution or providing a source control or volume reduction like the rainwater harvesting or green roof, or on-site treatment like sand filters, manufactured devices, and finally we go to a regional pond which will do either or both the pollutant load reduction and the runoff reduction. If for any reason we are not able to provide a facility, one can buy water quality credits from the NCB.
VDOT has developed a procedure for purchasing water quality credits from a nutrient credit bank that is based on DEQ regulations. If the total disturbed area for a site is less than 5 acres, or if the nutrient reduction required for HUC is less than 10 pounds per year, then it's possible to purchase 100% of the required load reduction as credit from a nutrient credit bank. If neither of these situations apply, but if 75% of the required nutrient reduction can be met within the HUC, then the remaining 25% load reduction could be purchased from a bank. It is possible to purchase more than 25% of the required phosphorus load reduction from a bank, but this requires DEQ approval and is decided on a case-by-case basis. Different studies have indicated the cost of credit purchase. One study is from the Virginia Center for Transportation Innovation and Research, and a second study is from the Center for Watershed Protection. These studies suggest that BMPs cost around $30,000 or $50,000 on average per pound of phosphorus removed. For comparison, the current cost of gold is $19,200 per pound, so providing water quality treatment does present a significant cost to stakeholders.
Having said that, let us get into how the design itself is done. As we said before, a project can have a number of hydrological unit codes. Linear development projects may have more than one, whereas site development projects might just be confined to one HUC. Each HUC will have to be checked for water quality compliance. Each HUC will have a number of outfalls, and each outfall will have to be checked for water quantity control, for channel and flood protection. In order to do this quality and quantity compliance, you install BMPs. These facilities, either they may be in parallel or in series, or they may be single units. Some outfalls need not have any BMP at all if they satisfy the 1% rule. We need to determine for each BMP the runoff and pollutant load reduction, and we aggregate it for each HUC and do the comparison of water quality compliance. Like I mentioned earlier, BMPs could be in series or in parallel, more than one BMP leading to one BMP, or the residual runoff from the upstream BMP is taken to the second BMP or the downstream BMP, and they will be accounted for in the net pollutant load reduction as well as the runoff volume reduction. Some BMPs might be a simple disconnection, and there could be some outfalls which receive direct runoff from offsite areas. In order to do the water quality compliance, DEQ has developed spreadsheets. VRRM compliance spreadsheets have been developed for both for new development as well as for redevelopment projects. Each workbook corresponds to a part of HUC. There are 10 worksheets for each. The first is the site data for the HUC itself, and then we have up to 5 outfalls, sheets 2 to 6. Sheet number 7 is the water quality compliance sheet. 8 is a channel and flood protection volume sheet, and 9 is a summary sheet. Redevelopment projects have similar worksheets. You will be able to work through these VRRM spreadsheets as part of the workshop. As you can see here, this is the HUC site area, and the bottom half of the sheet will give the treatment required. The total phosphorus load, the land disturbance greater than 1 acre, and impervious area post is less than pre, then 80% of the phosphorus reduction. Whereas if the impervious area post is less than impervious area pre, then the pH post should be less than or equal to 90% of the pre. Where the impervious area post is greater than that of the pre, then the criteria will be the added impervious area is treated as though it's a new development, 0.41 pounds, and the rest will follow ARB above. For linear development projects, however, we go by Part 2D, which is 0.8% of the pH pre. In any case, pH reduction need not be greater than that of new development.
These are the spreadsheets for the site area for redevelopment projects. As you can see here, you get your pre and post site areas for the HUC, and then the computations are done at the bottom of the sheet for the added impervious area and the remaining impervious area, and the total is accumulated at the end. Sheets 2 through 6 give the drainage area for each outfall, and any BMP that is provided in the column here shows the BMP credit areas. And for BMPs that are part of a treatment train, there's a column which will identify the downstream facility. Sheet number 7 is the water quality compliance sheet. It will tell you whether the water quality requirements are satisfied as a result of the BMPs included in the sheet. Sheet number 8 is the channel and flood protection sheet. The sheet calculates the adjustment in the CN values due to runoff reduction, but stops short of doing any further calculations. The participants will be able to work through these examples as well.
The new regulations has these 5 situations, and the performance-based criteria used to have these 4 scenarios. As for the outfall analysis for each outfall or the water quantity control, whereas 1% rule still applies, this is the total change in the philosophy of design. Whereas in the earlier regulations, we used to follow the MS-19 criteria for the Q2 developed should be less than or equal to Q2 pre-developed, or the 24-hour detention of Q1 developed, and the flood protection Q10 developed should be less than or equal to Q10 pre-developed. In the new regulations, the channel protection volume is determined based on energy balance method. It is not just the peak discharges, but also the total runoff volumes which are to be considered while determining the adequacy of the outfall. Q1, 1-year storm, is considered adequate for the energy balance methods. Q1 developed should be less than or equal to site development factor times the Q1 pre times RV pre divided by RV post. Site development factor is 80% or 90% depending upon the site area. Similar conditions apply for flood protection. So you will see that in order to do the energy balance, we need to make sure that the runoff volumes do properly account for the runoff reductions as well. So in the runoff reduction analysis per the new regulations, we determine the pre-project Q1, Q2, and Q10 for the total site area for each outfall for the existing land uses. using TR55 method. We do a similar analysis for the post-development conditions. We determine the runoff reduction volumes reduced as a result of the curve numbers and the TC adjustment, the reservoir storage, and simple disconnection. Based on these factors, the runoff volume reduction has taken place, and that is considered in the post-project Q1, Q2, and Q10 with the runoff reduction for the total site area for each outfall using the RV method, using TR55 method. The participants will do all this analysis using SwimSoft VA. Unlike the spreadsheets, InSoftTech has developed SwimSoft VA, a comprehensive design package which not only provides runoff reduction computations but also deals with the grandfather projects, that's the Part 2C of the regulations. The software does pollutant load reduction computations, discharge analysis using TR55. It carries out the runoff reduction analysis and does the energy balance equations for quantity control. The software goes further to design the stormwater management facilities, starting with BMP selection criteria, design of structural and non-structural BMPs, the low impact designs starting from green roof right up to wet ponds, reservoir routing based on the storage indication method given in VDOT drainage manual, and for wet ponds and constructed wetlands and the like, water balance analysis as well. The participants will be provided with evaluation copy of the software which they will be using to design the various BMPs. SwimSoft VA uses a database management approach. As a first step, you need to create a project. There's no limit to the size of the project. It can be a site development project or a linear development project. The project setup will be essentially project identification, the name, and the designer. Here we ask the question whether it's a linear development project or a site development project. There's a yes, no button here. The user will also be asked to identify if this is a grandfathered project coming under Part 2C of the regulation or if it is a new regulation project. Based on their response to these two questions, the program follows different routes or the different methods of analysis. The designer and the location are essentially reference information only. The selection of the county is quite important. You will get a pull-down list of all the counties and the principal cities of the Commonwealth of Virginia. When the user selects a particular county, the software brings up rainfall database from NOAA's Atlas 14 map for the TR55 as applicable to the particular county. The user can add as many HUCs. This is an expandable table. It could be 1 or it could be 10, and the table expands itself where the user identifies the HUC. We will go into the details of how the projects are set up, how the outfalls are identified, how the BMPs are selected, and how the water quality and the quantity analysis are carried out, as well as the physical design of the facility. It will be possible to design different stormwater treatment practices, both low impact designs or environmental site designs, and structural BMPs or more traditional BMPs. The outfall analysis for each contributing drainage area at the outfall, the pre-project and the post-project site areas corresponding to spreadsheets B to F of the VRRM spreadsheets are identified here. The user will also be required to fill in the receiving channel area to determine if 1% rule applies or not. If it does not apply, when you perform the analysis, the summary table will give the runoff reduction computations, channel protection volume, Q1. It populates all the values, rainfall depths, adjusted curve numbers, and the Q post with the runoff reduction analysis. On the right side, it computes the energy balance equations, identifies whether energy mass balance are satisfied or not. A similar analysis is done for the 10-year storm. The HUC summary will have only a couple of fields to be filled in. What is the disturbed site area? Depending upon the disturbed site area, which is less than or greater than 1 acre, the pollutant load reduction percentages are determined. If it is less than 1 acre, it's 10%. If it's greater than 1 acre, it's 20%. Again, when you click on performance analysis, all the computations are done and remarks will indicate whether the design is satisfactory or not. This sheet is very similar to sheet number 1 of the VRRM compliance spreadsheet. If it is new development, you will see only the right side of the site area. If it's a redevelopment project, you will see both pre-development and post-development site areas. There will be one summary sheet for each HUC, irrespective of the number of outfalls. The unique feature of this software is that all the folders are accessible at any stage. The user can interact with the BMP selection and the water quality requirement to determine the optimal design for the project. The user will have a hands-on experience of using the software in all the examples that will follow.
For these workshops, we have selected 3 example problems that are all VDOT projects. The first is a bridge reconstruction project, which is an example of a linear development project. The second is a new parking lot construction project, which provides an example of a site development project. And the third is an interchange reconstruction project, which is a more advanced linear development project where we will explore concepts like treatment trains. The bridge reconstruction project looks at the replacement of a pair of bridges on I-95 over Marin River. The project is in the city of Emporia in Greensville County, Virginia. Here's a view of the bridges. The image on the left is looking north, so the southbound bridge is on the left and the northbound bridge is on the right. The existing bridges are approximately 540 feet long and are each 32 feet wide. The stormwater drains on both sides of the bridge into the river. Under the proposed conditions, the northbound bridge will be widened from 32 feet to 44 feet. Approximately 1,300 feet of approach roads to the bridge will be reconstructed as well. The southbound bridge will also be widened to 44 feet, and approximately 2,500 feet of approach roads will be reconstructed. The participants will be provided data for this example project, such as that shown in this slide. The total site area is 12.72 acres. The post-impervious area will increase slightly from 4.36 acres before the project to 4.56 acres after the project. Under the performance-based criteria, 1.45 pounds per year of pollutant removal is required. The outfalls on the north and south side of the bridge to the river are 6.2 and 6.52 acres, respectively. Given that the receiving channel has a drainage area of 747 square miles, the 1% rule applies in this case. Here's a typical cross-section for the project. The green line shows the existing ground level, and the red line shows the proposed grade. The soil hydrologic groups for the site are mainly B and D soils. This map shows the 2 outfalls, one on each side of the bridge on the north approach. The proposed BMP is shown in the median. On the south approach, soil groups are primarily D, but the general setup is similar to that on the north side of the approach. There's very little right-of-way on either side of the project, and near the bridge embankments is the 100-year floodplain, so any water quality control would need to be done in the median.
The proposed activities for this workshop, as far as this example is concerned, is first we demonstrate the project, assuming that this will be a grandfathered project, in which case we use the VSMP performance-based design spreadsheets. Then we retrace the steps to determine the water quality requirements using the performance-based criteria, using VDOT spreadsheets. Then we do the same with the VSMP compliance spreadsheets. Then we set up the project using SwimSoft VA. We do the same analysis to determine the water quality requirements. We will also demonstrate a design of a bioretention facility. The participants will be asked to identify other BMP types and see how they can meet with the water quality compliance. We will go on to design the BMP facilities themselves. The first project will be followed by the two other projects. One is a new parking lot construction project and an interchange reconstruction project. Here is the VRE station and roadway improvement parking lot in Spotsylvania County. Provide both water quality and the quantity treatment for the parking lot project. This will be followed by the interchange project. This is a major interchange, Interstate 66 and Route 15 in Prince William County, interchange reconstruction project. The participants will have a very good understanding of water quality and quantity design based on these projects. As the participants work through the above examples, they will gain a good understanding on determining land disturbance areas, sizing of BMPs, bioretention, extended detention, dry swells, grass channels, wet ponds, etc. How to deal with treatment drains, runoff reduction analysis, checking energy balance, and channel protection and flood protection.
Thank you for viewing this webinar. If you're interested in participating in one or both of the Modeling Stormwater Best Management Practices workshops, further information can be found on the UVA CTS website at the link provided on this slide.